So again, thank you so much for inviting me at this conference. I think that this is the second time that I'm speaking, and I always really enjoy this conference, not only for the topics, the different topics and the technical approach that I learn from other speakers how they approach machine learning and how they develop AI solutions, but also for the community. The community is always important for me, and I noticed that last year that I got a lot of great questions during my presentation, but also after offline. So it's always a pleasure to be at this conference. So today, we are going to learn a little bit more about machine learning operations. So this is a topic I have been working on for the past few years now. I'm Francesca Lazzeri. I lead a team of engineers and cloud advocates at Microsoft. It's a very large and international team. We are based in the United States, in Canada, in UK, in Russia as well. And we work with external customers, but we also work with the product teams at Microsoft. And we noticed in the last few years that, yes, machine learning is beautiful. AI sounds very fancy, but the most important part is really the deployment and the operationalization of your machine learning models. And I'm going to explain you today, most importantly, how you can make sure that your end-to-end solutions are fast, but they're also somehow sustainable, meaning that you can implement those solutions and you can leverage those solutions in order to improve your business. So the first question that I want to ask you all today is, when do you think that a machine learning algorithm is actually becoming AI? And why you think it's so important? We can discuss this. I would love to hear your answers, also after these sessions or offline. I put my Twitter there. I'm also reachable through LinkedIn. But I really think that as a data scientist, as now a technical lead of a large data science AI team and engineering team in general, I think that it is important to understand that AI is a fancy, is a very cool, and offers companies the possibility to transform their operations. However, in order to be able to leverage these opportunities, companies have to learn how to successfully build, train, test, and most importantly, operationalize, deploy their machine learning models in production. So this means that really you need to learn how to push hundreds of machine learning models in production, and also it's important to move models, machine learning models, from development to their production environment in ways that are simple, robust, fast, and also repeatable. And nowadays, data scientists and developers have a much easier experience, I would say, when they need to build their AI-based solutions, because there is a huge availability of machine learning frameworks, and these frameworks are open source, as you can. However, this process becomes a lot more complex when data scientists and machine learning engineers in general need to think about model deployment and pick the best strategies to scale up to a production-grade system. So this is, again, extremely important. This is really the moment in which a simple machine learning algorithm is becoming AI, because without operationalization, without MLOps, is actually difficult to have a machine learning algorithm that is actually AI, meaning that other companies, other customers, other people in your business can actually leverage in order to get their results. Just to specify now, it's important to distinguish between model deployment and MLOps. So model deployment is really the method by which you integrate a machine learning model into an existing production environment in order to start using it to make practical business decisions based on your data. And MLOps is actually a little bit different. And let me go to the next slide to understand you, to explain you, and so that you can understand a little bit better what I mean with MLOps. MLOps is a discipline. I would say it's an area, very important area of machine learning that empowers data scientists, and I would say also app developers to help bring machine learning models to production. Most importantly, MLOps enables you to track, version, audit, certify, identify and reuse every asset in your machine learning lifecycle, and also provides orchestration services to streamline managing this lifecycle, which is great. Is exactly what we need right now in the industry. As you can see also from this slide, I like to think about machine learning ops, machine learning operations as a way to bring together people, processes, and platform to automate machine learning infused software delivery, and also provide continuous value to our users, because that is really the moment, as I was saying in my previous slide, where when machine learning is transforming into AI, into artificial intelligence. A lot of customers also ask me, how is MLOps different from DevOps? So there are many differences. In this slide, I try to summarize 4 of them. So first of all, as you can see, the data and modeling version is very different from the code versioning. So how to version data sets as the schema and origin data change. It's also important to mention that the model reuse is different than software reuse, as the model must be tuned based on input data and also based on your business scenario. The third important aspect is that digital audit trail lineage requirements change when dealing with the code plus data. And finally, I found that the model performance tends to decay over time, and you need the ability to retrain them on demand to ensure that they remain useful in a production context. So this is exactly what I think are the 4 key aspects of MLOps, and MLOps can help us with these 4 different aspects. It's also important to consider the difference between a traditional system and a machine learning infused system. Machine learning introduces 2 new assets into the software development lifecycle, and these 2 assets are data and models. And so, as you can understand, there are many more assets and a much more complex process that needs to be managed when you are creating end-to-end and sustainable machine learning solutions. And this is something that also Vlad was mentioning at the beginning of my sessions, that this means that actually the machine learning code is just a tiny part of the entire architecture that you need to build. It's extremely important. Data scientists should focus on that. It's their role to make sure that they have a beautiful machine learning code that is building a model based on different open source frameworks, deep learning, machine learning frameworks. You have honestly a lot of different options from TensorFlow, PyTorch. And so that is extremely important. However, it's not the only asset, as you can see, and most importantly, is not the, I would say, the most challenging right now. There are many other assets and processes that you have to think about, like configuration, data collection, feature extractions, data verification, machine resource management, analysis tools, serving infrastructure, monitoring, process management tools. So as you can see, this is a very complex scenario. So yes, the machine learning piece is extremely important, but it's not the only thing that data scientists and machine learning engineers and developers in general need to learn. Also, I like to summarize the most important pain points that our customers, and I'm sure this is something very general, everyone in the world, in the AI machine learning industry is recognizing these type of pain points. First of all, it's very hard to deploy a model for inference after that I have trained it. So it is very important to offer solution that somehow allow the no-code deployment for your solutions for models of common languages and frameworks. Here, I'm specifically referring, for example, to the Python family. Another important pain is that it's very hard to integrate the machine learning lifecycle into an application lifecycle. So we need to think about tools and processes to offer a production-grade model release with model validation, multi-stage deployment, and controlled rollout. It's also very hard, and I get this type of feedback from all the customers, to know how and when to retrain a machine learning model. So this is a very important that we are able to offer a model feedback loop with A/B scorecards and also drift analysis integrated with machine learning pipelines for retraining. Finally, one of the biggest complaints that I receive all the time is that it's very hard to figure out where my model came from and how it's being used. Because again, when you work in a huge data science team, engineering team, most of the time you have a few people working on the model and then other people taking this model and try to operationalize it. So this is again another pain point that we get all the time. And it's very important to offer an enterprise asset management with audit trail, policy, and quota management. So how do we implement the machine learning operations, MLOps, in the real world? So in the real world, I try to summarize what we have to deal with. There are many different jobs and tools that are involved in production of ML. Again, as a data scientist, I started my career as a data scientist many, many years ago at Microsoft, and I was focusing only on models. So as a data scientist, I recreated this experience. I was working like 10 hours on the machine learning. I was using, of course, Azure machine learning because my models were developed on the cloud, and I was a data scientist at Microsoft, so I was using Azure Machine Learning. I was using GitHub, open source frameworks like TensorFlow, PyTorch, scikit-learn, of course, different topologies of Azure Compute. But this is not the entire picture. This is what I was doing. But then I was working with a machine learning engineer, or I would say a lot of different machine learning engineers. And these people were using tools such as Azure DevOps, GitHub, Azure Kubernetes Services, Azure IoT Edge, Azure Monitor is another important tool. And then I was also working with a lot of data engineers. So they were helping with the data accessibility and also making sure that I could feed my model, my machine learning model over time and in a very clean way. And they were using tools like Azure Data Lake, Data Factories, Databricks, SQL. And then I was working with a lot of other people. So there were like IT ops person, there was the data analyst that was helping understanding the linkage between data and business. There was the business owners that in my case was always an external Microsoft customers, and many, many more. At some point, we also had the data visualization. So as you can see, it's a lot of people that are working together and are using very different tools. And there is very rarely one pipeline to manage the end-to-end process. When I say end-to-end process, I mean the end-to-end machine learning process. Usually, you start with a data engineer that is there to prepare the data, use the data lakes and the data catalog. Then usually I was taking care of the building the model and training the model. And this is, as you can see from this slide, it was about the featureization, training, evaluation. And then I was also able to register my model using a model registry. And then there is a machine learning engineer that most of the time release the model, and they are in charge of packaging, validating, profiling, approving, and finally deploying the model. And these results of the models then are collected again. We go back to a data lake type of scenario. So these are usually the different components that we define as one pipeline. However, they are never one pipeline. And it's really, when you think about machine learning operation, it's about a process maturity model. So this is, again, this is something that we have been noticing in the industry. There are many different levels of maturity. And I know that these tables look like very crowded and very dense, but this is all the data that we were able to summarize and somehow to put into a table to define the different levels of maturity right now for machine learning operations. So let's start with level one. Level one, there is no MLOps. And this it's a level where it's a very sort of interactive, exploratory, and the main goal of the data scientist in this level is really to get something useful, and most importantly, that is working. So that is meeting my accuracy level requirements, is also not consuming too much expensive resources. So this is really the role of the data scientist. But then what's next? Usually, most of the time here, you have still the data scientist that is able to use a model registry, and most of the time they are also able to leverage a sort of a run history service that is able to capture data sets, environments, code, logs, and metrics, and outputs. So again, this is more at the second level, and here you are trying as a data scientist to recreate a reproducible model training. So something that through different version code, data, ensure that the model can be recreated by different data scientists, by different developers in the company. And so you know very well how to use a model registry and a run history service. The third level, that is a little bit better than level 1 and level 2, is about automated model deployment, which is great. Again, here, most of the time you have a machine learning engineer who is taking the information and the assets that you are creating as a data scientist from the model registry, and then they are able to package the model, certify the model, and release the model through different environments. Which is very good level, I would say. Of course, the last level, this is level 4, where this is a level where we all should aspire to be there one day, is about automated end-to-end machine learning lifecycle. And here is the moment in which you have a data scientist, you have a machine learning engineer, and you have also a data engineer. As you can see here, you have all the different pipelines that I was describing before. They are very well integrated, and they are working together from the data pipeline, the machine learning pipeline, and also to the release pipeline. But let's see some real-world examples. We have been looking at machine learning operations for, as I said at the beginning of this session, for many years now, because it's the only key and is the only way to get into AI, into like really something that is working over time in a good way and really can help us accelerate the AI adoption for businesses and enterprises in general. So one way to look at MLOps is, for example, to ship recommender systems. Here, I put a GitHub link, as you can see, so I recommend all of you to go here. It's github.com/Microsoft/recommenders. In this GitHub repo, you can find a lot of different examples and the best practices for building recommendation systems provided as Jupyter notebooks. So in these examples, we try to summarize our key learnings on 5 key tasks that are preparation of the data. So how you can preparing and loading data for each recommender algorithm. Then we shared how we are building the model. So here is more about building models using various classical and deep learning recommender algorithms, such as the ALS, the alternating least squares, or also the, I think there also the extreme deep factorization machine. So these are all great algorithms for recommender systems. Then we share best practice on how you can evaluate the algorithms with offline metrics, how you can select your model and optimize it. This is about tuning and optimizing hyperparameters for recommender models. And finally, the operationalization, how you can operationalize models in a production-ready environment on the cloud. And so this is one of the architecture that we build, and this is really end-to-end examples on MLOps to ship recommender systems. However, we build many different MLOps, end-to-end MLOps, I would say, architecture. And here in these slides, you can see that there is a generalized one. So in this example, that again, you can generalize it to many different solutions. As you can see, we have a developer that is working on the IDE of their choice and on the application code. Then they commit the code to source control of their choice. In this case, for example, VSTS has good support for various source controls. Then in a different moment, there is a data scientist that is working on developing their model, and once they are happy, they publish the model to a model repository. And then a build is kick off in a BSTS base on the commit in GitHub. And this BSTS build pipeline pulls the latest model from a blob container. Can be extended also with a model management service. And this is important because it creates a container. After this, we have the VSTS that pushes the image to private image repo, in this case in Azure Container Registry. And then on a set schedule that usually is overnight, the release of this pipeline is kickoff. And then we have the latest image from ACR that is pulled and deployed across Kubernetes cluster on ACS. And finally, the user's request from the app goes through a DNS server, and this DNS server passes the request to load the balancers and sends the response back to the user. So again, here you have also a data engineer that is helping actually with the analysis of the signal for the retraining. So as you can see, these three roles are still very well integrated, and they are working together for one pipeline. So before we jump into the different tools that you can leverage in order to build a similar end-to-end architecture, I want also to make sure that you understand why the cloud in general is important for MLOps. And when I say the cloud, I'm not referring only to Azure, really, I'm referring to the cloud in general. Usually, the cloud is very important for any MLOps best practices and any MLOps process, because it contains a number of asset management and orchestration services that help you to manage the life cycle of your model training and deployment workflow. So in this case, with Azure Machine Learning and DevOps, you can manage your data sets, you can manage your experiments, models, and anything that is really a ML-infused application. Also, when you leverage the cloud, as you can see, you can use these to train, deploy, and automate your different machine learning pipelines. And these can be used also for any kind of machine learning, from classical machine learning to deep learning to supervised and unsupervised learning. And also, if you prefer to write in Python, which is right now, I think we all use Python or the R code with the SDK, or you can also work with, a more like a no code or low code options and experiences for you. In terms of the different tools that you can leverage, there is a dataset management and versioning. This is a way to bookmark the state of your data so that you can apply a specific version of the dataset for future experiments. And typical versioning scenarios usually are, like, for example, when new data is available for retraining, when you're applying different data preparation or feature engineering approaches. And by registering a dataset, you can version, you can reuse, and then you can share it across experiments and also with your colleagues. So this is extremely important. Then we have what we call the declarative machine learning pipelines. So a pipeline usually is a executable, what we call like executable workflow of a complete machine learning task. So subtasks usually are encapsulated as a series of steps within the pipeline. And the pipeline can be as simple as one script, for example, that one task that calls a Python script. So pipelines should focus on machine learning tasks, such as, for example, the data preparation, including also importing, validating, and cleaning your data, but also transform your data and process some of the most common tasks, such as, for example, the normalization of your data. So all of these is included in the data preparation part. Then there is a training configuration that is including also file paths, logging, reporting configurations. So this is, again, is about capturing all this information. There is also training and validating efficiently and in a repeatable way. And finally, there is also deployment, including versioning, scaling, provisioning, and also access control. So this is all about what we call the declarative machine learning pipelines. Then another important aspect and tools that you should consider is model management, packaging, and deployment. Machine learning operation is based on DevOps principles. That's why, also the name is similar, is MLOps. And so this DevOps principle that machine learning operation is leveraging are sort of a practice that can help you increase the efficiency of your machine learning workflow. For example, continuous integration, delivery, and deployment. And MLOps applies this DevOps principle to the machine learning process with the goal of faster experimentation and development of models, which is extremely important, faster deployment of models in productions, and most importantly, quality assurance. So again, this is something that you should consider. And in terms of capabilities that you should look at when you think about model management, packaging, and deployment, there are some of these capabilities are that, for example, you need to be able to create a reproducible machine learning pipelines. So you need to create reusable software environments for training and deploy your models. Another important aspect is that you need to register, package, and deploy models from anywhere. And then you need to capture the governance data for the end-to-end machine learning lifecycle. And finally, something that is also actually two things that usually I share with my team and they need to look at is one is that you need to notify and alert on events in the machine learning lifecycle. And the second is that you need also to monitor machine learning application for operational and machine learning related issues. I mentioned DevOps, so of course Azure DevOps integration is something that is offered at this point because it's very important in order to automate the training and deployment into existing release management processes. So sometimes it's important to have this integration with DevOps. And then another important aspect is the Azure Machine Learning Event Grid integration. This is a fully managed event routing for all activities in the machine learning lifecycle. You can also look at the setup of the setting up a data drift monitor. This is great, and I use it not all the time, but sometimes I use it because it's great in order to compare data sets over time and determine when to take a closer look. So this is something that is also nice. So I know that we are about out of time, so I want just to summarize this session. My goal really during this session was to share with all you the learnings that I collected over the years as a data scientist, as a lead of an engineering team right now, and also all the learnings from the customers in order to know how we can really implement MLOps for adoption of AI solutions. So a few key takeaways from these sessions are that, of course, DevOps is more about a mindset than really a tool. It's more like a portfolio of different tools that need to be used in a orchestrated way. Because MLOps really provides a structure for building, deployed, and managing, and also offer enterprise-ready AI application lifecycle. It's also important to remember that adoption will increase the agility, quality, and delivery of AI project teams, which is something that we are all aiming at, in the sense that we love machine learning, but of course we want our machine learning models to be deployed and to be leveraged by other teams and other companies. And finally, as I said, it's very important to think about MLOps more than a technology. It's really more like a conversation about people, process, and technology, AI principle, and also best practices that need to be understood by all the roles in your team. If you want to learn more, there is, of course, some documentation, especially in these two links. We have the aka.ms Azure ML Docs. And then the other one is a GitHub repo that is Microsoft/MLOps. Here you can find all the technical documentation that is pretty general. Again, it's not just about Azure, but it's more about MLOps on the cloud, which is extremely important at this point. And of course, if you have any feedback or you want to learn more, I'm also putting here a link that is aka.ms/AzureML_feedback in case you have additional questions or feedback. I really want to learn from your experience. Thank you very much for now. I hope you enjoyed this session, and I hope that I was able to share a little bit more of my learnings in the MLOps world. Thank you.
Thank you, Francesca. It's been quite informative. I wanted to ask a thing, actually. I noticed you're using a YAML pipeline when you were talking about machine learning pipelines. Would you recommend using those or sticking with the Python SDK?
So, of course, it depends on the situation and on the environment, on the production environment that you are planning then to use for the operationalization of your models. I can tell you what I have been seeing most of the time. Most of the time, I have to say that YAML file is actually the preference for customers, just because it allows a faster deployment and then also a reusable option when you need, especially to share assets that are already modeled, that you already picked, select, evaluate, and deployed. And so that is something that, for faster deployment and for faster execution of your end-to-end machine learning pipelines is what we use most of the time. Python is great for model development. As we know, there are so many open source frameworks that now data scientists can use. You don't need, as a data scientist, to build the models from scratch, but you can just leverage these beautiful frameworks. And so I would say let's stick with Python for the model experimentation, the model building, training, but then if there are additional options, let's use the best option.
Yeah, I think this mirrors my experience too, because a lot of time I saw a lot of confusion regarding, okay, I'm building the model with Python and I'm deploying it with Python, and where do we draw the line? So this, using the CLI for this might be a bit cleaner and easier to create a mental model.
Yeah, I agree, totally agree.
Thanks for clarifying this. I also have a question from the audience. How would you, so if you have a large model that takes a lot of time, say it takes an hour to train, how would you handle hyperparameter tuning for such a model in an automated way? Do you have any strategies here?
Yes, so if it is a model that is taking a lot of time, of course it depends on the stage that you are during the machine learning lifecycle. Like if you are still at experimentation, meaning that you are, and it seems from the question that yes, you are still trying to evaluate what's the best model based on your scenario and on your data. I would say the best tool that is right now in the industry is automated machine learning for hyperparameter tuning. And again, this is a sort of a feature that a lot of different cloud providers are using. There is the Google one, there is the Microsoft one, there is the AWS one, and there are also a lot of smaller players that are using automated machine learning, and they are offering their own solution. What it does, automated machine learning, is not just that it runs a lot of parallel pipelines for you, but it does at the same time the hyperparameter tuning for you and also the featureization for you. So in my opinion, this is a very healthy and safe option when you have long pipelines, and like trainings of your models is taken a lot, because again, you don't only leverage the parallel pipelines aspect, but you're also leveraging somehow an algorithm that is providing you a, I would say, fair option, like without introducing any additional bias that you can eventually introduce when you are building your model by yourself, and can optimize also the hyperparameter tuning for you. This is, again, it's based on many different scenarios that I have been studying over the years, and many customers that find themselves in this specific scenario that the person was asking about, they find automated machine learning, or is also called AutoML, very, very helpful.
Yeah, and I think also you need to take this this hit, right? So if you want the best model, you need to do some experiments, and you can either limit the space values you're looking at, or you can try maybe enhancing the data somehow.
Exactly.
In the hopes that will yield better results. But yeah. There's also a question: are there any tools or guidelines you recommend for deploying models on premises? You know, so not just in the cloud.
Sorry, this was I couldn't hear you. Can you repeat that?
Yeah, I stuttered a bit. So are there any tools or guidelines you recommend for deploying models on the premises? You know,
on the premises. Great question. So honestly, in terms of tools, no, because honestly, I think that if you're deploying the models on the on-prem or on the cloud, basically the same, you need to follow the same best practices. And I can share also offline with you, Vlad, a few articles that I wrote on model deployment that is about like what are the different assets that you need to look at for example, model registrations, and what are the different functions in Python that you need to write, like the init and run function. And these are all Python, functions. So independently, if you are on the cloud or you are on-prem, I would say there are a series of best practices that you need to follow that are the same. So, and plus remember that on-prem most of the time is used for experimentation purposes. And so when you are experimenting, even if you are building just a model and then you are deploying, it's still like the same practices, because then you're pushing everything to the cloud. So I will be happy to share this article where I share step by step of what you need to do for model deployment. But again, in this article, there are no differences between on-prem and on the cloud. It's just the best practices for model operations, for model deployment. Sorry.
Yeah, thanks. Please do, and I'll share them with the audience.
Yeah,
that would be great. All right. I think those were the questions I had.
Perfect.
Thank you so much, Francesca.
Thank you. And I hope, to talk to you, all of you soon. Thank you again.